Question 6 is the next important question on this worksheet. All the other questions, questions 1, 2, 3, and 5, are mostly quite straightforward. You should be able to solve those by yourself. But question number 6 is asking something totally new. I'm going to read the question and then consider the answer. It says, a farmer observes that black coat is dominant over white coat in pigs that he has. The farmer has a black male pig whose genotype is unknown. Right, let's write down what we know here. So we've got this pig, and I'm going to say big B is equal to black fur. I'm just making that up, it doesn't matter. And then the recessive would be the lowercase of big B, so small b would represent white. Right, now the farmer has a problem. He has got, and I'm just going to write it over here, just as like a little bit of a understanding what the question is asking. This farmer has a black pig. So let's put this pig into a little square like that, and assuming it's an individual. So we know that it's black. The only way to be black is to have a capital B, a dominant gene that makes the fur look black. But we can't tell if this is a big B, or a big B, small b. All right, so it could be homozygous black or heterozygous black. The farmer does not know. So what can the farmer do to demonstrate or to prove or to show if it's a homozygous or a heterozygous pig? Well, the farmer has to do one simple thing, and that is to breed his pig, his black pig, because both of these are black, to whatever it is, he doesn't know. If he breeds his black pig with a white sow, then it'll help him get closer to the answer of what the male pig is. So let's look at both possibilities. To do that, I'm going to just draw a line down the middle of my board here. So if the P1 generation was like this, and this is how we set out the P1 generation, super duper neatly, and his black pig was big B, let's assume it's big B, homozygous black, and he's going to mate it with a white sow. Now the only way the sow, female pig, can be white would be small b. So that's the one possibility, and let's straight away on the other side of the page put P1. This could also be a possibility. He mates his heterozygous black, that's a big B, heterozygous black pig, and again he mates it with a white sow. That is how he does it. Let's go and look at the Punnett diagrams. Now, let's be proper and neat here. I'm going to write gametes and put some circles for my gametes. That's very important. Not to get the boxes and the circles mixed up from a pedigree diagram, which is that of number 4, question number 4. Over here has to be a big B and a big B. Over here, small b and a small b. That's my dog, Spaniel. F1 generation. Let's draw the F1 generation. I might be doing this a little bit too small, but let's see if I can squeeze it in like that. Okay, I'm trying to create a bit more space. Right, so we take those gametes and we put them over there, put them over there. We take those gametes and we put them over there. So they're all heterozygous in the F1 generation, but let's be proper and write out genotype, and we just write big B, small b. There's no other options. There's only one solution there in the genotype. The phenotype, is that they all black. Right, let's leave that over there and come back to this possibility over here. I'm going to, just for simplicity's sake, now please don't do this. I'm just going to write, because I'm running out of space, G for gametes. I'm trying to keep my circles fairly large because this Koki's fat. And that would be big B, small b, and then small b, small b. If we go right down to the F1 generation, putting those gametes over there, and then these gametes down there. Right. Let's write out the genotype. Genotype, dot dot. 2 big B, small b's, and 2 small b, small b's. Let's write the simplest form. So it'll be big B, small b is to small b, small b. The phenotype would be heterozygous. It's 1 is to 1, 2 is to 2, same as 1 is to 1. So it'll be black is to white. So now having a look at this, we have two possible scenarios. If the pig was homozygous black, definitely all those little piglets would be black.
They'd be all blacks that probably play for New Zealand.
On the other hand, if he were heterozygous, then we have the possibility of a white piglet coming out. So the question might be that you might ask, what is the chance of having a white piglet if the male is heterozygous? Well, the chance of having a white piglet is 50%. Now, let's just say of these babies, there's only 2, and both are black. You cannot assume that he's homozygous black. For every time a little piglet is born in this side, there's a 50% chance if it's going to be black and a 50% chance it's going to be white. So you're not absolutely sure it's heterozygous if he has, or homozygous black if he has a black piglet. However, if he has a white piglet in this generation, then he has to be heterozygous. The only way that that white piglet could be white is to get one gene from mum and one gene from dad. So it'll be homozygous white, and that means dad would have had to be carrying the white gene. So that's one way to do it. Now, we've done a beautiful layout, we've done a beautiful presentation. I should have written the word gametes there, otherwise everything else is
perfect.
But we still haven't answered the question. Let's see what that looks like. This is the third part of answering this particular question. We've written down what we knew, we've worked neatly, and now we need to answer the question. Very, very, very important. So I'm going to write here. The farmer would, my dog again, would cross his pig with a white, and I'm going to put in brackets here, sow. And then if there was a white piglet, then his pig is heterozygous black, big B, small b. If he has many black offspring, then there is a high probability that it is homozygous black. Big B, big B. Now that sort of covers yourself, because even if he was heterozygous black, he could still have a black piglet. But you've covered yourself. So if he has many, and I think that's what you have to include here. If he has many black offspring, there is in fact, I forgot about that, there's a high probability that it is homozygous black. In other words, it could still be heterozygous black, and just every single time a piglet is born, it is black. That's like flipping a coin and getting heads every single time for a whole series of coin flips. The chances are slim. You're going to get a tails somewhere along the line because there's a 50-50 chance of getting tails. Right, so this is the last part. This is answering the question. I think this is comprehensive enough. In the past, I've written a much longer answer to say there's still a possibility you could still be heterozygous and have black piglets. But I think this answer would be sufficient. It really shows that you understand that black means that there's a bigger probability that he is homozygous black, where if there's a white piglet, for sure, he's heterozygous.